Okay, hello. Today we are working on question 6.14, 6.14. This one asks us to multiply and divide a whole number by a fraction, a whole number by a fraction. It looks a little bit trickier than it actually is because on both questions, and let me switch my pen from red, I'll make it a little bit obvious what we're doing, just so you can distinguish my pen from the black of the print. In both questions, we have to remember that whole numbers and fractions might be indistinguishable for the very reason that a whole number, for instance 5, might be expressed as a fraction, or in fact can be expressed as a fraction, by putting it over 1. And the reason for this is that fractions are just the same as division operations. 1 over 4 is the same as saying 1 divided by 4. We know if we put this into our calculator, I can do it right here. 1 divided by 4, it's going to give us 0.25. So we have a decimal here, which is the same, very similar as a whole number. For instance, when I turn my 5 into 5 over 1, let's just look at that as a division operation, 5 divided by 1, and you'll see 5 divided by 1, the number hasn't changed. 5 divided by 1, or 5 over 1, has the same value as 5. So it's totally okay to not distinguish between 5 and 5 over 1, which is going to make our life a whole lot easier when we are multiplying a whole number by a fraction, because it's much easier, it's much more comfortable to imagine ourselves multiplying a fraction by a fraction, or even dividing a fraction by a fraction. So I'm going to rewrite this question just to make our lives a little bit easier so we can recognize the fact that this whole number can be represented as a fraction and make our lives much easier. So I'm going to turn that into 5 over 1 times 1 over 4. And I'll rewrite this one as well. We've got 3 over 1 divided by 2 over 3. Okay. Now our lives are a little bit easier. We can see that we are multiplying a fraction by a fraction, and we may remember, or we may not remember, and that would be totally okay, that multiplying fractions and even dividing fractions, it's a whole lot easier than adding and subtracting fractions. We're used to multiplying and dividing being more difficult than adding and subtracting, but when it comes to fractions, it's actually the other way around. Multiplying and dividing fractions is much easier than adding and subtracting them, for the very reason that we don't need to find a common denominator. We don't need this number to be the same as this number in order to multiply or divide them together, because it just doesn't ask for that. We can very, very simply just do our denominator times our denominator, our bottom number times our bottom number. So 1 times 4, well, I'll do it on our calculator just so we're all on the same page. 1 times 4 is 4. 1 times 4 is 4. You only have 1 4. So that goes on our denominator for our answer, and 5 times 1 is 5. There we go. It's as simple as that. Now, some people might say, but Mr. Vaughn, this is an improper fraction. Our numerator is bigger than our denominator. If you are uncomfortable with that, I don't mind an improper fraction here or there, but lots of teachers, and me a lot of the time, will often ask you to put these in a mixed fraction. An improper fraction is not a final answer. We can do that by just seeing that 4 fits into this 5 once, so that's our whole number. And then after that 4 fit into that 5, there was 1 left over because 5 is 1 more than 4. So there's just 1 left over there, and our denominator stays the same. Our denominator stays the same there. You don't have to worry about that. But when we're changing a improper fraction into a mixed fraction, you just want to see how many times does your denominator, your bottom number, fit into your top number. That will make your whole number. And then what's left over? After the 4 fit into the 5, there was 1 left over because 5 is 1 more than 4. So that 1 went up here, and then our denominator stayed the same. So the answer here is 5 over 4 as an improper fraction, or, and I always want to circle our answer in red, 1 1/4, 1 1/4. Give it a nice bigger circle so it's not in the way. So 5 times 1/4 made for 1 1/4, or 5 quarters. Same thing. Now, dividing a whole number by a fraction is going to work very, very similarly. We've already done the simple part of turning our whole number into a fraction so we can work with it much more easily. But now we need to do the additional step. Sorry to change my color so frequently. We need to do the additional step that dividing by a fraction asks of us and do what I call the old switcheroo. So, the old switcheroo. We are going to simplify this because right now it looks a bit complicated. You might be tempted to say that, well, should I do 1 divided by 3? And that'll give us the denominator, and then 3 divided by 2, and that'll give us the numerator. That would be a good leap of logic because it would follow the logic of multiplication. But unfortunately, this isn't as logical as we would like it to be. When we are doing the switcheroo, we're actually going to make our lives, once more, a little bit easier. We're going to keep the same first number, 3 over 1, and then we are actually going to do the weird thing of flipping our second fraction. Flipping our second fraction. So 2 over 3 is going to become 3 over 2. The old switcheroo. We flipped our fraction, and then this division that was right here, we were doing 3 over 1 divided by 2 over 3, it's actually going to become multiplication. Isn't it crazy? Yes. So, now that we have a multiplication problem after our old switcheroo, we can just do 1 times 2. Well, that'll give us 1 times 2 is 2. And then our numerator, 3 times 3. 3 times 3 is 9. So as an improper fraction, the answer we have here is 9 over 2. Now, many people would not be satisfied with an improper fraction. They might want to turn it into a proper fraction, into a mixed fraction, something where the numerator isn't larger than the denominator. Because this, if it would be like I ate 9 out of 2 slices of cake, improper fractions don't make sense a lot of the time when we put them into the real world, which is why we would like to put them into a mixed fraction where they make more sense. So once more, to turn a improper fraction into a mixed fraction, we want to see how many times the denominator fits into the numerator. So this was a 2, so 2, 4, 6, 8. If I do this 4 times, I end up with 8. If I did it 5 times, I'd end up with 10, which would be more than the numerator. I don't want to go that high. I don't want to be more than the numerator. How many times does the denominator fit inside the numerator? Well, if I did it 4 times, I would be at an 8. So it'll be 4 times. And at that 8, there's still 1 left over. 1 left over in this fraction because I got this up to an 8 by doing it 4 times. And this is a 9, which is 1 more than 8. So there's 1. 1 left over. And then our denominator stays the same. So we end up with 4 and a half. 4 and a half rather than 9 over 2 or 9 halves. This makes more sense. You could say I ate 4 and a half pies rather than 9 halves of a pie. You can see why we prefer to speak in mixed fractions. They just make more sense in the real world. And lots of teachers will ask you to turn your answer into a mixed fraction rather than leaving it as an improper fraction. But you can see we took our dividing a whole number by a fraction. We turned it into a fraction divided by a fraction, just like we did over here. We turned our whole number into a fraction by putting it over 1. And then we did the old switcheroo. We flipped the second fraction. It was 2 over 3. It became 3 over 2. And that turned our operation from a division into a multiplication. And from there, we were on easy street. We just did 1 times 2 to get our denominator down here, and 3 times 3 to get our numerator up here. We took that number, which some teachers would accept, an improper fraction. This is true. Improper fractions do exist in the real world. They're just sometimes uncomfortable to look at. We turned that into a mixed fraction by seeing how many times did this bottom number fit into the top. That became our big whole number here. And then whatever was left over became our numerator, and the denominator stayed the same. So 2 fit into 9 4 times, which gave us 8. So there's your 4. 8 to 9 is 1. There was 1 left over right there. And then our denominator stayed the same. So 4 and a half was the answer here. Over here, I'll just go over it once more. We took our whole number, 5, we turned it into a fraction, so it was 5 over 1. And then, easy street, we did our denominator times our denominator. 1 times 4 gave us 4. And our numerator times our numerator. 5 times 1 gave us 5. This gave us an improper fraction, 5 over 4, and we did the same process. How many times does 4 fit into 5? Well, only once. If we tried twice, 4 times 2 would be 8. It would be more than 5, so we can't do that. So it was once, which became our whole number, and then there was only 1 left over. 4 fits into 5, 1, with 1 left over. That 1 left over becomes our numerator, and the denominator stays the same. So now you know how to multiply a whole number by a fraction, and even better, with an additional step, you know how to divide a whole number by a fraction. Just remember to turn them into fractions, your whole numbers into fractions, and then if you're dividing, remember to do that old switcheroo, because it's much easier to work with multiplication on fractions than it is to do crazy things with division. So, you know how to do these now? I want you to give them a try. Godspeed, good luck, you can do it.